All right, welcome back. All right, so in this video, we're going to go through different scenarios that might arise when talking about forces, net forces acting on different objects. Maybe there's more than one object, inclined planes, non-inclined planes, all sorts of different stuff. I'm going to go through as many types that I can. I can't get to everything. I can't keep adding things as they could keep adding things. But I'm going to do my best, and between this video and the other videos and the notes, that should help you piece together whatever it is you need pieced together. So let's start with the most basic, and that is a single object on a horizontal surface. Okay? Very simple. What you first need to do is make your net force in the x equations and your net force in the y equations. Okay, you've got to take clues from the problem and decide which forces are moving horizontally, your x, which forces are moving vertically, your y. If there's a force that's diagonal, make sure that you appropriately break that force into horizontal and vertical components using the f cosine theta or fy or f sine theta, depending on what you need, to plug into here. Make sure you understand which direction it's accelerating. Is it accelerating up? Because if it's accelerating vertically up, then the acceleration in the x will be 0. If it's accelerating horizontally, the acceleration in the y will be 0. If it's accelerating some other way, you've got to approach that in that way too, right? Key thing there is make sure you keep your dimensions separate and make sure you properly read the question. Is there friction? Well, if there is, then that's going to be a force that you need to take into account, right? Things like that. You're going to have to look at the problem and really create your equations based on the scenario given in the question. Okay? Let's do another one. Let's go with a single object. But this time, it's not on a surface, it's just in equilibrium, right? So there's no normal force. You've got maybe two angles, right? Something like this. It's like a sign hanging out in front of a store or something. Well, again, first step, make your net force in the x and your net force in the y equations. Okay? Luckily, usually for this, the MA will equal 0 because it's going to be in static equilibrium. So that's good, that helps. Right? But then again, what you're going to do is take your forces that are horizontal, put them here. Your forces that are vertical, put them here. As we can see, we have two forces acting on this object that are diagonal. So you're going to have to put the components of each of those forces for each of these objects. Make sure you keep the direction in mind, right? Horizontally, these are going in opposite directions. There should be a negative sign in your x. Vertically, these two are going in the same direction. There should be a plus sign between these two. But gravity is acting down, so gravity should be subtracted from these two, right? And then just go from there. Let's say, for example, they ask you to solve for the tension of each of these objects. Well, then you'll have to do a system of equations, solve for, like, create an expression for the tension of one object, plug that into the other equation, solve for a number, take that number, plug it back into the expression you made for up here, and just calculate through. Okay? Next one. Okay, let's talk about more than one object on a horizontal surface. This can look a couple different ways. We can have objects A and B in contact like this. We can have objects A and B in contact like this. Or we can have objects not in contact, but maybe connected by a string or a spring or something along those lines. Right? Maybe there's a string over here. That's how the force is applied. Maybe there's a force here. Okay, to solve this, what you'd want to do is make a net force equation, F net x and F net y, so your horizontal and vertical, for both. For both. Okay? The acceleration for all of these systems will most likely be the same, right? Especially if this string is taut. The acceleration of this is going to be the same. The acceleration of this is going to be the same. But how you write the forces for each object will be different. For example, let's take this one, right? Take block A. It's got a force of its own weight down. It's also got the force of weight of block B on it down, as well as a normal force from the surface up. But block B has just its own weight acting down, and the normal force between block A and block B acting up. So block A will have 3 forces, block B will have 2 forces, right? You're going to have to make sure that even though they have the same acceleration, you write your net force equations for each object to then appropriately go through and solve for what you need to go through. Because of the fact that your acceleration is the same, that's really helpful. For this one here, the tension, especially if this is a nice ideal taut string, the tension will be the same on each object. Okay? Is there friction here? Make sure you take that into account. A lot of different things you got to worry about when solving these problems. Okay? Great. Now, what if instead of the objects being on a horizontal surface, there is another dimension involved? Let's start with something like this. You have 2 blocks attached by an ideal string over a massless, frictionless pulley, and they're kind of hanging on like that. Okay? Now, hopefully, the pulley is massless. If it's not, well, then you're going to have to take some rotational motion stuff into account, and it kind of muddies up the problem. But if it's nice and massless and frictionless, and this is an ideal massless string, then you know your tensions are the same, your accelerations are the same, so you can just set your net force equation, net force x, net force y, for each object. So 2 equations for this one, x and y, 2 equations for this one, x and y, so 1x, 1y, 1x, 1y, okay? And go through and solve. One thing to remember is that the more massive object will accelerate down. So let's say your block B, so the mass of block B has a greater mass than block A. Well, in that case, block B will accelerate down. When that is the case, you've got to make sure that this acceleration for block B has the same sign as the force of gravity, the weight of block B. Right? You've got to make sure you keep your signs in check. If they go in the same direction, you add them. If they go in the opposite direction, you subtract them. You get to pick which side is positive or negative, but you've got to be consistent the whole way through. Great. Great. Okay, now, what if there's 2 objects connected by a string over a pulley, but this time one object is dangling off the edge of a table while one object is on the table or surface or whatever it is. Very similar to the previous problem. Create a net force equation, x and y, for both objects. Keep in mind the tension and the acceleration is the same for both objects. You may need to do a system of equations. Set each net force equation that has tension in it equal to tension. Set those equal to each other. Solve for what you need to solve for. Go through. Okay. Maybe there's friction here. Maybe there's some other force this way that you have to take into account. Ooh, that's a backwards force. That was the correct force for me. F, I mean. Okay. Take a look at the problem and see what they got. Make sure that you keep your signs consistent and you're good to go, right? This is all the same kind of stuff. The key things to keep in mind were all discussed in that other video. Make sure your signs are consistent. Make sure you have a net force equation for the X and the Y for every scenario, for every object involved, and keep some approximations in mind. Ideal strings, the tension will be the same the whole way through. If it's a massless pulley, great. We don't have to worry about anything with the mass. Okay, so just keep that all in mind. If it does have a mass, the pulley, right, what that's going to end up doing is causing it to not accelerate the same rate, because it's going to take some acceleration just to move the pulley itself. So that's going to kind of affect it a little bit. Okay. Let's see. All right, I'm just making sure my notes here. Now, all these scenarios that you've seen here so far, they can be approached very similarly through an inclined plane. Okay. The only two that won't be will be the ones where you have the strings holding a sign or the vertical pulley. Right. So let me show you an example. Oh, look. Here I have a single object on an inclined plane. Same basic rules. Oh, look, it's attached to another object through a string. Same basic rules as that one. Okay, create net force equations for each object. Maybe there's friction, maybe there's not. Maybe there's a pulley right here. Okay, it goes up and over, and this is nice and vertical. And let's see, make sure I make that nice and vertical. Okay. If you have a scenario like this, you'll only treat the object on the inclined plane like an inclined plane. This one, you can have a standard axis. This one, you'll have to make sure it's rotated, which means you'll have to keep in mind that your weight force, the components will be switched, so it'll be Fx equals F sine theta and Fy equals F cosine theta. But this one you can keep regular. The tension will be the same, the acceleration will be the same. Okay? They're all common factors. They all have common factors to each of these problems. Just go through each object, create a net force equation for each object in as many dimensions as you can, properly break any diagonal forces into the appropriate components if need be. Make sure that you're keeping everything consistent. You're taking into account all forces. I know I'm kind of just saying the same thing over and over again, but they're just that important. Okay? I hope this was helpful. I apologize I can't go through every single problem or give a practice problem for every single scenario here in this video. But hopefully between the notes and the other videos, you should be able to piece together whatever it is you need to piece together. Have a good one.